Thank you. Thanks a lot, John, for that really generous introduction. So it's a great privilege to be here addressing you today. I thought what I would do today is tell you how viruses can also be our allies. I think viruses have a bad rap, and I'll tell you why they deserve that bad rap, and then I'll show you some ways that we can actually put them to use and make them actually useful. Can everyone hear me? Sidipta, can you hear me? Is it through the microphone that you're hearing me? Okay, good. All right, so viruses are actually used as tools to do chemistry in my own laboratory, and I like to think of these as power tools. These are really powerful ways of getting at difficult chemical reactions, things that otherwise would be really challenging to deal with. We actually can tackle using viruses. So what I'm going to do today is show you that, but before I do, I have to introduce you to the whole idea of viruses, how they work, what their basic parameters are, and then I'll introduce you to a couple of bad ones and a good one. And then I'll show you how we take the good one and put it to work on our side for once, get it to actually do some useful chemistry. And specifically today, I'm going to be focused on diagnostics. I think viruses offer us a way of shifting the paradigm for what's possible in medical diagnostics. And I'm going to show you how we're doing that in my laboratory. And that's the major topic of today. It's something new called virus electrodes that my laboratory is inventing. Okay, so straight up, the first question I always get whenever I'm sitting on the plane and I tell someone who's sitting next to me that I work on viruses, the first thing they always ask me is, are viruses alive or dead? And evidently this has been long debated. And what I usually tell them is something along the lines of, I'm not really sure. Okay? The truth is they have some characteristics of being living, and then they also have some other characteristics that don't make them living. So let's first talk about what it is to be alive. Okay, so we all agree that this guy, running across the Serengeti Plains is alive, right? He's definitely alive. So what is it that makes this guy alive? And this has been a long debated question, and people who are a lot smarter than me came up with very good answers to this. For example, Crowfoot, a chief of the Blackfoot Nation in Canada, who lived 1830 to 1890. One of his last statements, he was a philosopher and a chief, was, here's what life is. What is life? It is the flash of a firefly in the night. It is the breath of buffalo in the wintertime. It is that little shadow which runs across the grass and loses itself in the sunset. And to me, this really is exactly what life is, right? Crowfoot got it right. This is exactly true. Every single thing that Crowfoot says is one of the characteristics that biologists and chemists like myself have agreed upon are one of the characteristics of life. So for example, that flash of the firefly, fireflies are doing this to find mates. It's a characteristic of reproduction and heredity, the passing on of genetic information to the next generation. That's a characteristic of life. The breath of the buffalo, metabolism, right? All things that are living are taking in food and using this to generate energy. Running shadows, that's motility. All living things can move, including plants, incidentally. They can move very slightly to shift towards sunlight. And then this business about being lost in sunset. All living things, unfortunately, will die. Okay, that's an absolute fundamental characteristic of life. Now, viruses, it turns out, really don't follow all those criteria. Okay, so if we look at viruses, yeah, they can do reproduction and heredity. In fact, that's more or less what they exist to do. And I'll show you the life cycle in a moment, but that's basically their raison d'etre. Okay, that's what they want to do, is basically make more copies of themselves. Now, metabolism, viruses can't do metabolism. Viruses are also incapable of moving. They have no motility that's available to them. However, viruses also have a few extraordinary attributes which transcend life. They can actually do things that living things cannot do. And one of those is they can overcome death itself. Okay, so whoever said, one thing is certain is death and taxes, viruses don't follow those rules. They don't pay taxes, that's for sure. And they also can be regenerated after death. So for example, if you take viruses like these and kill them using UV light, you'll chop up their genomes into big, big fragments. Okay? And it turns out that the viruses can actually re-splice together those fragments and regenerate phoenix-like afterwards. Now, there's almost nothing else on the planet that's capable of that thing. Okay? So viruses really don't fit in the category of living or dead. They're neither. Okay? They're not quite dead, even when we think they're dead, and they're not quite living either. Okay, so as far as I'm concerned, viruses are interesting to study because, like living creatures, they evolve. They respond to their environment, they undergo selective pressure, and it's those attributes that my lab puts to use.